Okay, welcome to video lesson 4.4, Equations as Relations. Go ahead and put today's date, and by the end of the lesson, we will hope that I can determine and find solution sets for equations. Okay. Now, start us off with a couple of vocabulary words. Our first vocabulary word is equation and two variables. Equation and two variables just means that the equation has two variables. It's usually x and y, but sometimes they can use other variables. But for the most part of what we'll see for equations as relations, we'll see variables x and y in our two variable equations. Now, a lot like how we did back in chapter 3 when we solved equations, if needed, sometimes we'll have to solve for y. Just how this one right here is solved for y equals, we'll need to solve for y if it's not already. Okay, our second vocabulary word is solution. And solution is an ordered pair. So if you remember, ordered pairs have your x and your y value in them. So solution is an ordered pair that results in a true statement when substituted into the equation. And true just means that it works. So solution is an ordered pair that results in a true statement when substituted into the equation. Okay, now that we have our two vocabulary words, let's see how they apply to an example. So we have example 1. And we're given or asked to find the solution set for y equals 2x plus 3. Given the replacement set of negative 2, negative 1, negative 1, 3, 0, 4, and 3, 9. And we're going to do this by making a table. So if you notice, I went ahead and made a table that has 1, 2 smaller columns and a third really big column. And what we're going to do is we're going to come above here and label out the variable. So I use the variable x. I use the variable y. It tells me that y equals 2x plus 3. And over here we want to know if it's true or not. So the way we find if the solution set or the replacement set is true is by just coming over here and doing exactly what the definition said. Substitute. So we're going to say my very first ordered pair here is negative 2, negative 1. So the x value is negative 2, y value is negative 1. So down here, x is negative 2, y is negative 1. We're going to substitute it into our equation. So y, well, the y value is negative 1 equals 2. And if it's times x, it's now going to be 2 times x is now negative 2 plus 3. So drop down my negative 1, nothing happens to him, but say 2 times negative 2 is negative 4 plus 3. And I can do negative 4 plus 3, so negative 1 equals negative 1. And then it wants to know, is that true? Is negative 1 equal to negative 1? Yes, it is. And we're going to do this for all of our ordered pairs. So we did our first one. We can check him off and go on to our second order pair. So we are given negative 1, 3. So our y value for this one is 3 equals 2 times x is now 2 times x is negative 1 plus 3. So 3 equals 2 times negative 1 is negative 2 plus 3. And finish that off, negative 2 plus 3 is 1. So is that true? Does 3 equal 1? No, it doesn't. So, no. That means it's false. Okay. Extend my table here just a little bit. And we can say we got our second order pair. Now we're off to our third one, 0, 4. So I'm going to replace my y value with 4 equals 2 times my x value is 0 plus 3. So 4 equals 2 times 0 is 0 plus 3. 4 equals 0 plus 3 is 3. Once again, we're asked if that's true. No, it's not, so it's false. And our last ordered pair is 3, 9. So extend my table one last time. X value is 3, y value is 9. So y value 9 equals 2 times x is now 2 times 3 plus 3. So once again, my 9 drops equals 2 times 3 is 6 plus 3. So 9 equals 6 plus 3 is 9. 9 equals 9, so is that true? Yes, it is. So, when we're asked to find the solution set for the replacement set, I need to come off to the side here and say the solution, and then just take the ordered pairs that did work. So, if I come up right here and say the first order pair, -2, -1 was a yes. So that was a solution. So -2, -1. And also the other one that gave me a yes was 3, 9. So the solution set for this one would be -2, -1 and 3, 9. Because these two were the only two ordered pairs that worked. Now sometimes they'll give us our solution set, or our replacement set, and make us find the solution. What we're going to see next is when they just give us the replacement set and we have to find the solutions. So it says solve, so example 2, solve b equals a plus 5 if given the domain. So if you remember from 4.3, the domain is all your x values. Well, we're not working in terms of x and y, we're working in terms of a and b. So if you think about it, in the alphabet, x comes before y, and in the alphabet, a comes before b, x is now going to be our a values because it comes first in the alphabet. So for when our a values are -3, -1, 0, 2, 4. So we make our table same way we did over here. We went x then y, kind of like it is in an order pair, kind of like how it is in the alphabet, x then y. So in the alphabet, my a would come first. And we know my a values are -3, -1, 0, 2, 4. But I don't know my b value, so I'm going to have to put b way over here and have to solve for b. So b equals a plus 5. And then lastly, I'm going to have to solve and write them out like an ordered pair. So in an ordered pair, we know x comes first, then y. Well, in terms of a and b, a would come first, then b. Okay, now what we're going to do is we're just going to come and list out our a value. So our first a value is -3. I don't know b, I'm solving for b. So I'm going to say b equals, a is -3 plus 5. And b equals, -3 plus 5 is 2. So over here our b value is 2. In order to pair AB, our a value is -3. Our b value is 2. And we're just going to come through and do this for each number of our domain. So our next domain is -1. So -1, we have b equals -1 plus 5. -1 plus 5 is, -1 plus 5 is 4. So b equals 4, so over here b is 4, and our ordered pair is negative 1, 4. Okay, our next value is 0. So b equals 0 plus 5, and 0 plus 5 is 5. So our b value is 5, and our ordered pair is 0, 5. Okay, our next domain is 2. Ooh, that was a little crooked. Let's try that again. So 2, so b equals 2 plus 5, and 2 plus 5 is 7. So b equals 7, our b value is 7, and our ordered pair is 2, 7. Our very last one of our domain is 4. So 4, and we have b equals, a is now 4 plus 5, 4 plus 5 is 9, so b equals 9. Our b value over here is 9, and our ordered pair for this one is 4, 9. Now, we solved for our b value by plugging in what we know for the domain. So for this one, our solution set for this equation would be our ordered pairs over here, in our last column. Okay, so this very last column over here, where we have our ordered pairs, this is our solution set. So when our domain is -3, -1, 0, 2, 4, our solution set is -3, 2, -1, 4, 0, 5, 2, 7, and 4, 9. Now, on some problems, they may ask us to take this a step farther.